Hi everyone, how are you my dear children? After long time, 4-5 days gap, again I am shooting this video. I was busy with some work, so couldn't post the video. Okay, so last class or last video lecture, what we have discussed? We have discussed about the velocity, average velocity and uniform velocity. Today we are going to discuss about acceleration. Okay, what does it mean? Acceleration. So velocity means how fast your vehicle or object is traveling or moving. Okay, and when the velocity of a body is increasing, then what we will tell? The body is said to be accelerating. So when velocity increases, we say it is accelerating. Okay, how to understand this? Suppose a car starts from rest. Here it is V is equal to 0. This is your starting point. Okay, a car started traveling or moving from this point. So here V is equal to 0. Clear children? So this is your initial velocity. Now velocity increases. When car starts moving, velocity increases at a steady rate. It is not changing. It is not variable velocity. It is changing or increases. Velocity increases at a steady rate. How? So that after 5 seconds, it has started with 0. Okay. So after 5 seconds, the velocity becomes 10 meter per second. Now clearly you can see the velocity is increasing and it is a steady rate. With this rate, in next 5 seconds it will be again 10 meter per second. Okay. Now what does it mean? So that means in 5 seconds the velocity increased from 0 to 10. Then what is this amount? What is how much? The increased velocity. How much? 10 minus 0, final velocity minus initial velocity. So it is 10 meter per second. Okay children, the velocity has increased by 10 meter per second. So in 5 seconds it is increasing by 10 meter per second. Tell me in 1 second how much? In 1 second. Clear children? In 1 second the velocity increases by how much? 10 divided by 5, that is 2 meter per second. Per second, because this is meter per second and this is second. So it is now 2 meter per second again per second. So what does it mean? This means it is 2 meter per second square. Clear children? This is 2 meter per second square. What does it mean? That means in every second the velocity increases by 2 meter per second. 2 meter per second square means the velocity is increasing by 2 meter per second in each second. In each second velocity is increasing 2. In next second it will be 4 meter per second. In next second it will be 6 meter per second. Like this it is changing. So this is your acceleration only. So what is acceleration? Acceleration is nothing but change in velocity with time. Clear children? And you will denote as A. So acceleration is nothing, change in velocity per second or rate of change in velocity. Rate of change in velocity means it has to be divided by your time. So change in velocity divided by time. What is this time? This time is time taken for this change. Clear change children? When there is rate means you have to divide by 10. Or you can write change in velocity means final velocity divided by, subtracted by initial velocity. Final velocity minus initial velocity divided by time taken. How much time has been taken for the change in this particular velocity. That means A is equal to, if final velocity is V and initial velocity is U, divided by time taken. Clear, children? Okay. So A is the acceleration of the body, V is the final velocity, U is the initial velocity, T is the time taken. What is the SI unit? Just we have seen SI unit is meter per second square or centimeter per second square or kilometer per hour square, or you can say kilometer, you can write kilometer square of the hour, or you can write kilometer h to the power minus 2. That also you can write. And whether acceleration is a vector quantity or scalar quantity, when there is velocity, velocity is a vector quantity divided time taken, so it is a vector quantity again because it has got direction. Clear, children, till now? Okay. Now, when the velocity of the body is uniform, what does it mean? Let us see. When the velocity of the body is uniform, velocity is uniform, that means the change in velocity will be what? When body is moving with uniform velocity. Uniform velocity means there is no change in velocity, children. Then what is your acceleration? Acceleration will be 0 because initial velocity, final velocity Vf minus Vi divided by T. Vf, final velocity, and initial velocity both are same, so it will get cancelled. So acceleration will be 0. Clear, children? Since change in velocity is 0, so when a body is moving with uniform velocity, acceleration will be 0. Clear? Now we will see there are two types of acceleration: uniform acceleration and non-uniform acceleration. What is this uniform acceleration? What does it mean? Uniform acceleration. Suppose a body is having uniform acceleration. First, a body has to move in a straight line. If body is traveling in a straight line and its velocity increases by equal amounts of time, in equal intervals of time, what does it mean? Suppose this is your starting. Here velocity is 10 meter per second. After 2 seconds, velocity will be 20 meter per second. After again 2 seconds, the velocity will be how much? 10, 20, it has to be 30. Then only it is a uniform acceleration or uniform acceleration. When body has uniform acceleration, when it travels, okay, when it travels equal distance, 10 meter per second. See, equal, it travels in a straight line and its velocity increases by equal amounts. Every 2 seconds, 10 meter per second. Every 2 seconds, 10 meter per second. Your velocity is increasing in equal amounts in equal intervals of time. Then this body will have a uniform acceleration. That means if velocity changes at uniform rate, if velocity changes at uniform rate, then it is called uniform acceleration. See here. Tell me what is the acceleration over here. How to calculate in this case? For this part, how to calculate uniform acceleration? Tell me, children. Final velocity minus initial velocity for this case. I am telling you for this case. A is equal to, you can write A1. In this case, suppose A1. So A1 will be V minus U, final minus initial. So 20 minus 10 divided by 2. So how much? 10 by 2. 5 meter per second. Clear? Now suppose this acceleration from this to this, can term it as A, B, C. Now from B to C, what is the acceleration? It will be 30 final minus initial. So 30 minus 20 again by 2. How much? Again 10 by 2, 5 meter per second. See how the velocity, every 2 seconds the velocity is increasing 5 meter per second. So this is called uniform acceleration. Okay, and here, sorry, it will be second square, because this is second, this is second. Clear, children? What are the example of this uniform acceleration? Tell me. When a body is falling freely, body is over here, it is falling. When body is falling freely, that means motion of a freely falling body is nothing but example of uniform acceleration. At a uniform rate, velocity will increase. Clear, children? Or you can say another example also, when the ball is rolling down in an inclined plane. When, suppose this is a ball is now coming down like this. This is also the motion of a ball rolling down an inclined plane is also an example of uniform accelerated motion. Uniform motion accelerated because velocity is continuously increasing at a uniform rate. Clear, children, what is uniform acceleration? Then we will discuss what is non-uniform acceleration. What is non-uniform? This is easy now. Once you know uniform means, it is easy to get non-uniform. Non-uniform acceleration means velocity increases by unequal amounts in equal intervals of time. Okay, how to? Suppose starting point 10 meter per second. Okay, here I will write suppose 20 meter per second. Okay, here I will write how much? I will again slow down, I will apply a brake, 10 meter per second. Here suppose 10, it is now on non-uniform, okay. Suppose it is 40 meter per second, and in every 2 seconds we are measuring, in every 2 seconds. See, velocity is increasing in, this is unequal, this is 10, now this is again, this is increasing, this velocity is increasing, here velocity is decreasing, here again velocity is increasing. So velocity increases by or changing, this velocity is now changing, the rate of change of velocity is different in each time. Okay, so here the body has non-uniform acceleration. What is the acceleration over here? Tell me. 20 minus 10 in first case, 20 minus 10 by 2. How much? This is 10 by 2. We will say 5 meter per second square, children. Now in this case, A2. A2 will be how much? 10 minus 20. 10 minus 20 by 2. So it will be minus 10 by 2. So it will be minus 5 meter per second square. And this is your A3 suppose. So what is A3? 40 minus 10 divided by 2. Okay. So how much it is? 40 minus 30 by 2. See, is it uniform acceleration, children? This is non-uniform acceleration. Hope it is clear to you people. What is non-uniform acceleration? Okay. Now let us see this case. What is this? Now acceleration is there, but there is a negative sign. What does it mean? This is nothing but negative acceleration, children. This is nothing but negative acceleration or simply retardation. Retardation, or you can say negative acceleration. Okay, or you can say deceleration. Acceleration, right? Deceleration. It all same, different terms. Okay, that means when the velocity of the body is increasing, there you are getting acceleration. Now what we have seen in last example, the velocity is decreasing. So when the velocity of the body decreasing, then the acceleration will be negative. Okay, so a body is said to be retarded. A body is said to be having negative acceleration when the velocity decreases. Clear, children? So same formula, change in velocity by time taken. Okay, same unit, meter per second square, everything same, but there will be a negative sign. There will be a negative sign. So negative sign means, or negative value of acceleration means, velocity of the body is decreasing. Okay, so acceleration is final velocity minus initial velocity divided by your time taken. Okay, suppose your velocity, you are moving with a velocity of 10 meter per second. Clear, children? And suppose I am driving a car having velocity 10 meter per second. Okay, now what will happen? I will apply a brake now. Okay, I will apply a brake. Then obviously car will come to rest. And the car will come to rest. So this is your initial velocity Vi. So what is your final velocity? It will come to rest means velocity becomes 0. And to come to rest, it has taken the time, suppose 5 seconds. Okay, children? Is it visible, children? Okay, either you can write Vf or Vi simply, or you can write initial velocity as U and final velocity also V. That also you can write. It is up to you. Okay. In all 10th class book, it is like a 9th class book, it is like U and V. So it is up to you. You can write V minus U. Same. So now final velocity is 0. Initial velocity is 10 divided by 5. So what is your acceleration now? Minus 10 by 5. So minus 10 by 5 means minus 2 meter per second square. Is it clear, children? Minus 2 meter per second square. This minus, this is your, this shows it is the acceleration, that means body is accelerating but in negative way. That means velocity is decreasing. Okay. So this negative sign only shows it is a negative acceleration or retardation. Is it clear, children? Value will be same, children. That is plus 2 for positive acceleration and minus 2 will be for negative acceleration. Negative means, negative sign means immediately will come to know कि velocity is decreasing. Positive means velocity is increasing. Hope I am clear with this. Okay? Okay, children. So in my next class we will discuss the equation of motion. Okay? Hope it is clear. If possible, I will try to solve some numericals also. Clear, children? Okay. Take care, children. Thank you for watching. Hope this video lecture has helped you in some way to understand the 9th class syllabus in an easier manner. Okay? Thank you for watching, children.